Hello, and welcome to PsyBox. What if we are not the first? Take a moment and consider that question. Look around you. At our world, at our sprawling, illuminated cities, our satellites carving silent pathways across the night sky, our global network of information flashing across the planet in an instant. It feels solid. It feels permanent. It feels like the pinnacle of this planet's long, slow journey towards consciousness. We are the inheritors of Earth, the first and only species to bend the very elements to our will, to leave our mark not just on the land, but on the very atmosphere and the space beyond. This is the story we tell ourselves. But what if it's a lie? What if this entire grand project of human civilization is not a premiere, but a rerun? An echo of a song that has been sung on this world before, a repetition of a cycle of intelligence, technology, and perhaps oblivion. This idea feels unsettling. It feels like it belongs in the realm of myth, of sunken continents, and forgotten magical ages. But what if it is the most logical conclusion to be drawn from the single greatest fact about our planet, its incomprehensible age? We are accustomed to thinking in human timescales in generations, centuries, millennia. Our entire recorded history, from the first Sumerian clay tablets to the device you are watching this on, is a mere 6,000 years long. The Great Pyramids of Giza, which seem to us like monuments from the dawn of time, are younger, in the grand scheme of things, than the last living woolly mammoth. Now, contrast that with the age of the Earth, 4.5 billion years. To make that number comprehensible, imagine the entire history of our planet as a single calendar year. The Earth forms on January 1st. The first, simplest forms of life appear by late March. For the next 6 months, April, May, June, July, August, September, the planet is inhabited only by microbes. The first complex, multicellular animals don't appear until early November. The dinosaurs arrive on the scene around December 15th and rule the world for 2 full weeks until the great asteroid impact on December 26th. And us, humanity, our entire recorded history, every king, every empire, every war, every book, every discovery, all of it takes place in the last 10 seconds before midnight on New Year's Eve. The question, then, is not whether there was enough time for another civilization to arise. The question is, what was happening in the vast, silent, unrecorded swaths of that year? What was happening in the millions of years between the extinction of the dinosaurs and the rise of the first hominids? What was happening in the billion years before that, when the continents were a different shape and the sky was a different color? The history of our planet is a book with 1 billion pages, and we have only read the last, torn-out sentence. To assume that our story is the only one written in that book is an act of profound arrogance. So, if another civilization did exist, where are the signs? This is the point where the search usually turns upwards to the stars. We have been conditioned to look for answers in the cosmos. We spend billions on telescopes to search for habitable exoplanets. We build colossal dishes to listen for faint radio signals from distant galaxies. The search for extraterrestrial intelligence, or SETI, is one of the grandest scientific quests we have ever undertaken, driven by the hope that we might one day hear a friendly voice in the cosmic static. But after decades of listening, the silence from the stars has been absolute. This has led to a great and chilling cosmic question, the Fermi paradox. If the universe should be teeming with life, where is everybody? We have spent so long staring up into that silence that we have failed to listen to the silence of our own world. We are like detectives who have cordoned off an entire planet as a potential crime scene, but are spending all of our time and resources interviewing the neighbors in the next solar system without ever stepping inside the house itself. What if the solution to the Fermi paradox, the reason the sky is so quiet, is that we have been looking in the wrong direction? What if intelligence is not a rare cosmic phenomenon, but a recurring planetary one? What if the greatest alien civilization we could ever hope to find is not in the stars, but in the deep, unwritten history of the Earth? If we accept this staggering possibility, the next question is, where would we even look? If a civilization of land dwellers like us had existed millions of years ago, we would surely have found something by now: a fossilized tool, the ruins of a city, a strange seam in the rock. The fact that we have found nothing of the sort suggests one of two things. Either no such civilization ever existed, or we are looking in the wrong place. And there is one place on this planet, one vast, colossal, and almost entirely unexplored realm that has been hiding in plain sight. It is the true final frontier, a world more alien and less understood than the surface of Mars, the abyss, the deep ocean. The sheer scale of our ignorance is a fact worth dwelling on. Over 70% of our planet is covered by water. The average depth of that water is nearly 4 kilometers. This means that the vast, overwhelming majority of the Earth's biosphere, the space where life can exist, is not the thin film of the surface and atmosphere, but the colossal, three-dimensional volume of the deep ocean. We have mapped the surface of Mars and the Moon with such precision that we know the location of almost every crater. Of our own planet's ocean floor, we have mapped less than a quarter to a comparable resolution. And mapping is not exploring. The percentage of this deep world that a human being or a camera has ever actually laid eyes on is less than 1/100th of 1%. It is, for all intents and purposes, a completely unknown world. Let us take a journey there. We leave the sunlit surface, the world we know. As we descend, the pressure builds with a relentless, crushing force, and the light begins to fade. We pass through the twilight zone, a world of strange, ghostly, bioluminescent creatures. Then, at a depth of about 1,000 meters, the last photon of sunlight is extinguished. We have entered a new universe, a realm of absolute, eternal blackness, and of a cold that never varies. It is a world that has been this way for not just millennia, but for eons. It is a world of almost unimaginable stability, and it is here, in this dark, stable, and completely unexplored realm, that we propose our central hypothesis. What if the first, and perhaps greatest, civilization on Earth was not like us? What if they were not children of the sun, but children of the Earth's own internal fire? What if they were not land dwellers, but abyss dwellers? What if a form of intelligence arose in the crushing pressures and absolute darkness of the deep ocean, their entire existence powered by the chemical energy erupting from hydrothermal vents on the seafloor? A civilization that never saw the sun. A civilization that never knew the stars. A civilization whose entire history, a story that could be millions of years long, played out in a world we are only just beginning to realize exists. This is the incredible possibility we will explore. We will investigate the science that makes this seemingly impossible idea plausible. We will imagine the strange and wonderful form such a civilization might have taken, with a technology and a perception of reality completely alien to our own. And we will become detectives, searching for the faint, ghostly traces that this lost empire might have left behind in the eternal dark. This is not a search for little green men in the stars. This is a search for the echo of a lost Earth, for the ghosts of our own planet. To even begin this investigation, we must first ask, is such a thing even possible? Could a world without light truly become a cradle for a mind? The hypothesis, then, is this. The answer to the Fermi paradox is not an absence of life, but an abundance of it, hidden in a place we have systematically ignored. But to truly appreciate the scale of this possibility, we must first recalibrate our understanding of our own planet. We are surface dwellers, and our perspective is profoundly skewed. We think of the biosphere as the green and brown parts of the globe, a thin, fragile film of life clinging to the continents. But this is an illusion. The true biosphere of Earth is the ocean, and its scale is almost beyond human comprehension. It is not a question of surface area, but of volume. The entire terrestrial biosphere, from the deepest roots of the Amazon rainforest to the highest flying bird in the sky, occupies a relatively tiny vertical space. The oceanic biosphere, however, begins at the surface and extends downwards for miles. 99% of the living space on planet Earth is in the ocean. Let's try to visualize this. Imagine you could take the entire terrestrial biosphere, every forest, every desert, every mountain, every city, and every living thing within them, and place it inside a single, massive box. To contain the entire oceanic biosphere, you would need a warehouse that could hold over 300 of those boxes. We are not living in the main house, we are living in the garden shed. This colossal volume is a world defined by a single, overwhelming physical force: pressure. At the surface, we live under what we call 1 atmosphere of pressure, the gentle weight of the air column above us. It is so constant, we do not even feel it. As we descend into the ocean, that pressure increases by 1 full atmosphere for every 10 meters of depth. This increase is relentless and linear, and its consequences are extreme. In the twilight zone, at a depth of 500 meters, the pressure is 50 atmospheres. It is a force that would crumple a modern military submarine like a tin can. At the average depth of the ocean floor, around 40 meters, the pressure is 400 atmospheres. This is a force equivalent to balancing a stack of 3 luxury cars on your thumbnail. And in the deepest trenches, the Hadal zone, at nearly 11 meters, the pressure exceeds 100 atmospheres. This is a force so immense it is difficult to describe with analogies. It is a force that fundamentally alters the way molecules behave, that compresses water itself, and that would turn any surface organism into a biological slurry in an instant. This is not just another environment. It is a different physical reality, and it is a reality of eternal, absolute darkness. It is a world without seasons as we know them. It is a world without day and without night. It is a world of profound geological scale stability, where the only clock is the slow, patient decay of radioactive elements and the even slower drift of the continents. This combination of colossal volume, extreme pressure, and eternal, stable darkness makes the abyss the most perfect hiding place imaginable. It is a universe within a world, a place where an entire evolutionary history, a story as long and as complex as our own, could have played out completely unseen. With this in mind, let us return to the Great Silence and the Fermi paradox, the Drake equation, and our entire search for extraterrestrial life contains a series of hidden, unspoken, surface-dwelling assumptions. It assumes that life will arise on the surface of a terrestrial planet. It assumes that intelligence will evolve in an atmosphere, and it assumes that any technological civilization will inevitably develop technologies like radio that broadcast their existence across the void. We have been searching for our own reflection in the cosmos. But what if intelligence is not a surface phenomenon? Let us propose a new solution to the Fermi paradox. Perhaps the great barrier to galactic colonization is not a great filter that destroys civilizations, but a great wall that contains them. Most life in the universe may not arise on cozy, Earth-like surfaces, but in the deep subterranean oceans of tidally heated moons, or, as on our own planet, in the abyssal depths of a water world. For a civilization born in such an environment, the challenges of space travel are not just immense, they are orders of magnitude greater than for a surface-dwelling species like us. We had to overcome the gravity of our world and the friction of a thin atmosphere. An abyssal civilization would have to first overcome the colossal, crushing pressure of their own ocean. They would have to invent a technology capable of surviving a pressure differential of 1,000 atmospheres, a materials science so advanced it would seem like magic to us, just to get a probe to the surface of their own planet. From there, they would still have to reinvent rocketry to escape their planet's gravity. It is entirely plausible that for a civilization born in the deep, their entire technological and philosophical trajectory would be inward-facing, not outward. Their space race would not be to the stars, but to the even more extreme pressures and temperatures of their own planet's core. Their concept of exploration would be to delve deeper into the crust, perhaps migrating to the theoretical, deep Earth oceans of the mantle. The sky, a place of impossibly low pressure and strange, deadly radiation, would be a far less compelling frontier. In this view, the silence of the cosmos is not the silence of a graveyard. It is the silence of countless deep, warm, and comfortable homes, populated by civilizations that have no ability, and perhaps no desire, to shout into the cold, empty void of space. Their destiny is not to colonize the galaxy, but to explore the universe within their own world. This, then, is the grand, audacious hypothesis we will investigate. We will proceed with the assumption that our planet has hosted two separate, intelligent lineages, the children of the sun and the children of the deep. To build our case, we will embark on a structured investigation, a journey in 4 more parts. First, we will explore the hard science. We will not ask you to take this on faith. We will journey back to the moment of discovery that proved life could thrive without the sun, and we will unpack the incredible biological engine of chemosynthesis that makes this entire idea scientifically plausible. This will be the foundation. Then, having established that foundation, we will do what science fiction does best. We will become architects of the impossible. We will build a detailed, logical, and deeply alien vision of what this civilization might have been like, their technology forged from life and stone, their senses tuned to a symphony of darkness, their very consciousness shaped by the crushing embrace of the abyss. After that, we will become detectives. We will ask what ghostly traces, what improbable anomalies such a world might have left behind. We will learn how to search for the ruins of a civilization that left no ruins, for the fossils of a world that left no fossils. We will hunt for the faint, lingering echoes of their existence in the rock and the mud of the deep. And finally, having journeyed through the science, the speculation, and the search, we will ask the most important question of all. What does this story, the story of our planet's lost children, tell us about ourselves? What can the silence of the abyss teach us about our own future? This is not just a story about aliens. It is a story about the profound limits of our own imagination and the staggering secrets that may yet be hidden in a world we thought we knew. So, open the box and let's descend together. In our introduction, we opened a box of profound and unsettling possibilities. We have put forth the audacious hypothesis that we, humanity, may not be the first intelligent civilization to call this planet home. We have suggested that the great silence of the cosmos is not an answer but a misdirection, and that the true story of intelligence on Earth may be hidden in the one realm we have barely begun to explore, the crushing, eternal darkness of the deep ocean. This is a grand and dramatic claim, and it rightly invites skepticism. To move this idea from the realm of speculative fiction into the light of plausible reality, we must now build a case. We must answer the immediate, burning question that this hypothesis creates. Is such a thing even remotely possible? To do that, we must first confront the single, monolithic assumption upon which our entire understanding of life has been built. We must examine what I will call the solar axiom, the belief that all complex life on Earth is and must be a child of the sun. This axiom is not an arbitrary dogma. It is born from millennia of every observation we have ever made. Life, as we have always known it, is a solar phenomenon. It is a planetary scale miracle of engineering, powered by a distant star. At the heart of this miracle is a single elegant process: photosynthesis. It is the foundation of our world. Within every green leaf, every blade of grass, and every microscopic cell of marine algae, there exists a sophisticated molecular machine that captures the energy of photons and uses it to weave together carbon dioxide and water into the simple sugars that are the fundamental currency of life. This process not only creates the food that sits at the base of every food web we know, but in doing so, it releases the oxygen that fills our atmosphere and allows our own air-breathing biology to exist. Every ecosystem we have ever studied is a testament to the sun's power. The teeming biodiversity of a rainforest is a testament to the fierce competition to capture every last ray of light. The great migrations across the Serengeti are dictated by the seasonal patterns of sun-fed grasses. The vibrant, shallow-water coral reefs are built upon a symbiotic partnership with photosynthetic algae. We are so utterly dependent on this solar engine that the very idea of a complex ecosystem existing without it was, for most of scientific history, considered a physical impossibility. Even our first forays into the deep ocean seem to confirm this rule. The Great Challenger expedition of the 1870s, which first systematically dredged the abyssal plains, brought back a host of strange and wonderful creatures from the deep. But every single one of them was correctly identified as a link in a long chain that led back to the surface. The deep-sea food web was understood to be a world of scavengers, a system entirely dependent on the gentle, constant rain of marine snow, the organic detritus of dead plankton, and surface creatures that falls like a perpetual light, dusting into the darkness. The abyss, therefore, was seen as an energy-starved desert, a world of profound scarcity, populated only by the desperate few who could survive on the last, pathetic crumbs from the sun's distant table. This was the unquestioned truth of biology, but the history of science is a story of unquestioned truths being shattered by unexpected discoveries. And in 1977, the solar axiom was about to be executed. The revolution did not begin in a biology lab. It began aboard a cramped, pioneering deep-sea submersible named Alvin on a mission that had nothing to do with discovering new forms of life. The team aboard the vessel, on a dive to the Galapagos Rift, some 2.5 kilometers beneath the waves, was composed primarily of geologists and geochemists. Their mission was to study the raw geology of a mid-ocean ridge, a place where tectonic plates are spreading apart and the Earth's crust is being born. They were there to test a theory that hot water should be percolating up through the sea floor, and they wanted to sample it to better understand the chemical balance of the oceans. The biologists on the expedition were there on the off chance they might spot a few unusual fish adapted to the cold, barren, volcanic terrain they expected to find. Imagine the scene inside that tiny, 2-meter titanium sphere, 3 human beings, crammed shoulder to shoulder, descending for an hour and a half into a world of absolute blackness. The pressure outside builds with every passing meter, a silent, monstrous force that will soon reach over 250 atmospheres. The temperature of the water plunges to just 2 degrees above freezing. Their only connection to the world of air and light is a crackling radio link to their mother ship, a tiny speck on the waves miles above. This is an environment more hostile and less forgiving than the vacuum of space. As they near the bottom, their sonar indicates they are approaching their target area. They switch on the sub's powerful external lights, and a brilliant cone of white cuts through a darkness that has been absolute for longer than humanity has existed. At first, the view through the tiny, thick portholes confirms their expectations. A bleak, alien landscape of black, pillow-like lava flows, a sterile, volcanic desert. But then, the external temperature probe begins to climb. The water outside the viewports starts to shimmer and waver, distorted by heat. They are close. They pilot the sub towards the source of the shimmer. And then, everything changed. Illuminated by Alvin's lights was a scene of such impossible, shocking vibrancy that the scientists were stunned into a state of bewildered awe, their exclamations captured on the mission's audio logs. "Isn't the world beautiful?" one stammered. "Look at that. It's all alive down here. Where there should have been a barren wasteland, there was an oasis, a dense, thriving garden of life." The rocks were covered in thickets of giant tube worms, some taller than a person, their pure white chitinous trunks topped with brilliant, blood-red plumes that swayed in the shimmering currents. They were a biological riddle. Creatures with no mouth, no gut, and no anus, yet growing at an astonishing rate. The ground around them was paved with giant white clams, the size of dinner plates, their flesh a startling bloody red, a sign of hemoglobin they shouldn't have possessed. Ghostly white crabs, completely blind, scuttled over every surface, navigating by senses unknown. There were strange, tethered creatures that looked like dandelions, and fish that were previously completely unknown to science. This was not just the discovery of a few new species. This was the discovery of a new world, a new biology, a second independent genesis for life on our own planet. It was the biological equivalent of landing on an alien planet and finding it teeming with a biosphere that operated on a set of rules completely different from our own. The discovery of the hydrothermal vent ecosystems was a profound paradigm shift. It shattered the solar axiom into a million pieces, and it opened the door for our hypothesis. If a complex, thriving, and completely non-solar ecosystem could exist in the abyss, it proved that the deep was not a desert. It was a cradle. It was a place with its own internal, planetary energy source. And this realization has profound implications, not just for the story of our own planet, but for the search for life everywhere. If life can thrive in the crushing, toxic, lightless depths of our own ocean, then why not in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus? The impossible garden of the Galapagos Rift gave us a new hope for finding life in the universe by revealing a secret, alien world that had been hiding on our own planet all along. The discovery of the hydrothermal vent ecosystems in 1977 was a moment of profound revelation. It was a single, shocking observation that sent a seismic shockwave through the entire field of biology. The impossible garden, thriving in a place of eternal darkness and crushing pressure, presented scientists with a fundamental question that had to be answered. What was powering it? If not the sun, then what? The answer, they would find, was the planet itself. The engine of this dark world was a process that had been theorized for microbes but never imagined on this scale: chemosynthesis. To understand this process is to understand the very foundation upon which our entire hypothesis is built. Let us begin with the fuel source. At a mid-ocean ridge, like the Galapagos Rift, the Earth's crust is thin and fractured, a mere wound in the planetary skin. Cold, dense seawater, at just 2 degrees above freezing, percolates downwards through these deep cracks, sometimes for miles. As it descends, it approaches the vast, incandescent chambers of magma that lie just beneath the seafloor. Here, it is heated to astonishing temperatures, often exceeding 400 degrees Celsius. The only reason it does not instantly flash into steam is the colossal pressure of the miles of water above it. In this superheated, supercritical state, halfway between a liquid and a gas, the water becomes a powerful and corrosive solvent. It strips the surrounding basaltic rock of its minerals and chemicals, becoming a hot, acidic, and metal-laden brew. The most important chemical it picks up on this subterranean journey is hydrogen sulfide, H2S. To us, this simple molecule is a well-known poison. It is the chemical that gives rotten eggs their noxious smell. If we breathe it in, it binds to the iron in our hemoglobin and effectively suffocates our cells from within. To the creatures of the vent, however, it is not a poison. It is the gasoline that fuels their entire world. This hot, buoyant, and now chemical-rich fluid then erupts violently back into the freezing ocean through the hydrothermal vents, creating the shimmering plumes and the great, towering chimneys of the black smokers. It is here, at the violent interface between the planet's inner fire and the ocean's cold embrace, that the miracle of chemosynthesis takes place. The master chemists of this entire operation are the bacteria. These chemoautotrophic microbes are the true primary producers of the abyss, the dark equivalent of the forests and grasslands of our world. Photosynthesis on the surface uses the energy of a photon from the sun to crack open a water molecule, releasing energy. Chemosynthesis in the deep uses a different trick. The bacteria have evolved a suite of unique and complex enzymes, biological machines that allow them to do something extraordinary. They absorb the hydrogen sulfide molecule from the vent fluid and, through a controlled chemical reaction, they oxidize it. They systematically break the chemical bonds holding the hydrogen and sulfur atoms together, and in doing so, they capture the burst of chemical energy that is released. This captured energy is then used to power a second, entirely separate process, the building of life. Using this chemical energy, the bacteria drive a process called the Calvin cycle. the very same metabolic pathway that plants use to take carbon dioxide dissolved in the seawater and convert it into simple sugars, like glucose. These sugars are the universal fuel for life, the basic building blocks for everything else. The waste product of this reaction is not the life-giving oxygen of photosynthesis, but simple sulfur and water. So the parallel is complete. Photosynthesis uses light to turn CO2 into sugar. Chemosynthesis uses poison to turn CO2 into sugar. One is a biological solar panel, the other is a biological geothermal power plant. This discovery was revolutionary, but it also presented a new puzzle. It was one thing to prove that a microscopic film of bacteria could live this way. It was another thing entirely to explain the dense forest of giant, complex animals. How did the energy get from the microbes to the macrobes? In the surface world, the answer is simple: you eat the plants. But in the abyss, the solution was far more elegant. The answer was to cut out the middleman entirely through the triumph of symbiosis. Let us return to the giant tube worm, Riftia pachyptila, the poster child for this impossible world. The riddle of its mouthless, gutless existence was solved when biologists discovered that it is not a single animal, but a perfectly integrated, co-evolved partnership. The worm's brilliant red plume is a marvel of biochemical engineering. It is packed with a unique form of hemoglobin that has two different types of binding sites. One set of sites does what ours does. It grabs onto oxygen molecules from the ambient seawater. The other set of sites is designed to grab onto the lethal hydrogen sulfide molecules from the vent fluid, but in a way that renders them inert and non-toxic to the worm's own tissues. It is a biological delivery truck that can safely transport both fuel and an oxidizer in the same bloodstream without them reacting. This chemical payload is then transported to the worm's largest internal organ, the trophosome. This vast, spongy structure is not for digestion. It is, in essence, an onboard hydroponics factory. It is packed to an unbelievable density with trillions upon trillions of symbiotic chemosynthetic bacteria. The worm's circulatory system delivers all the raw materials, oxygen, CO2, and the hydrogen sulfide fuel directly to these internal partners. Safe inside the worm, the bacteria work their chemical magic, producing a vast and continuous supply of sugars. They produce so much, in fact, that the massive surplus is released directly into the worm's bloodstream, providing all the nourishment the giant animal needs to grow at its astonishing rate. The worm is a living house and a sophisticated delivery system. The bacteria are the resident farmers. The result is a creature that has become a self-sustaining ecosystem. This incredible strategy of internalizing the food source is the dominant and most successful way of life in the abyss. The giant vent clams also have gills packed with their own symbiotic bacteria. The strange yeti crab uses the hairy bristles on its claws as a personal garden, cultivating its own crop of chemosynthetic bacteria, which it then harvests for food. The strategy is clear. In a world where the food source is a microscopic film living in a toxic chemical bath, the best solution is not to eat it, but to become its home. This reveals that the creatures of the abyss are all specialists of the extreme. They are extremophiles, organisms that don't just tolerate their brutal environment, but are fundamentally adapted to it and often require it to live. The thermophiles, or heat lovers, that cluster around the vents have evolved proteins and enzymes that are held together by stronger molecular bonds and are assisted by a suite of heat shock proteins that constantly repair and refold their cellular machinery, allowing them to function at temperatures that would instantly sterilize any surface organism. The piezophiles, or pressure lovers, of the deep trenches have evolved unique fats in their cell membranes and a suite of organic molecules called piezolytes that maintain the structural integrity of their cells under pressures that would crush a human lung to the size of a Colorant's marble. Their bodies require the pressure to function. In the low pressure of the surface, they would literally fall apart. Add to this the acidophiles that thrive in the acidic vent fluid and the halophiles that live in deep-sea brine pools more saline than the Dead Sea, and a picture emerges of a biosphere that treats the laws of physics and chemistry not as constraints but as suggestions. The sheer tenacity and creativity of life in these environments proves that no challenge is too great, no puzzle unsolvable. We have now established the pillars of possibility. We have a proven non-solar engine in the form of chemosynthesis. We have a thriving, complex biosphere of extremophiles that have mastered their brutal environment through the elegant solution of symbiosis. We have demonstrated that life is not just tenacious, but endlessly creative, capable of conquering any physical or chemical challenge the planet can throw at it. But all of this, as remarkable as it is not enough. For an ecosystem to progress from a garden of strange creatures to a cradle of intelligence, it requires one final, non-negotiable, and incredibly precious ingredient: time. Vast, uninterrupted, and stable periods of time. This may be the single most compelling reason to consider the abyss a more likely birthplace for continuous, complex evolution than the surface world we call home. For all its beauty, the surface of our planet is a place of profound and recurring violence. The evolutionary story of surface life is not a smooth, continuous climb. It is a brutal saga of catastrophic setbacks, punctuated by planetary-scale disasters that have repeatedly and violently pushed the reset button. Consider the event 66 million years ago that ended the 150 million year reign of the dinosaurs, when an asteroid the size of Mount Everest struck the Yucatan Peninsula. It did not just cause a large explosion. It triggered a global firestorm, followed by a dark, choking impact winter that lasted for years. The sun was blotted out by a thick shroud of dust and soot, and without sunlight, the great engine of photosynthesis ground to a halt. The plants died, the herbivores that ate them starved, and the carnivores that ate them followed. It was a complete collapse of the global food web, an extinction event that wiped out 75% of all species on Earth. And that was not even the worst of it. 252 million years ago, the Permian-Triassic extinction event, known to paleontologists as the Great Dying, was an apocalypse of almost unimaginable scale, triggered by a series of colossal volcanic eruptions in the Siberian traps that lasted for nearly 1 million years. This event pumped a catastrophic amount of carbon dioxide into the atmosphere. The result was runaway global warming, which in turn caused the oceans to become anoxic, devoid of oxygen, and highly acidic. Over 90% of all life on Earth was extinguished. Our planet came terrifyingly close to being rendered a sterile ball of rock. And these are just 2 of at least 5 great mass extinctions we know of, not to mention countless smaller but still devastating events like the snowball Earth periods, where the entire surface of the planet may have been locked in a tomb of ice for millions of years. The surface world, our home, is a cosmic shooting gallery, a place of constant, violent interruption. The abyss, by contrast, is the planet's ultimate bomb shelter. It is almost completely decoupled from the chaos of the surface. An asteroid impact, the colossal thermal mass of the global ocean, would buffer any temperature change to a negligible degree, and with no reliance on sunlight, the chemosynthetic food web would continue its work, completely oblivious to the winter raging miles above. An ice age? A sheet of ice a mile thick might grind across the continents, but the eternal night of the deep would remain unchanged. A supervolcano? The effects would be devastating, but largely contained to the surface and the atmosphere. The hydrothermal vents, powered by the planet's own internal radioactive heat, would continue to pump out their life-giving energy, utterly indifferent to the fire or ice that define the world above. This provides a continuous, unbroken evolutionary runway that can last for hundreds of millions of years. This is the long, quiet, predictable environment where evolution has the time it needs to conduct its most complex, most energy-intensive, and most time-consuming experiments. It is the perfect incubator for building a brain. But even in a perfect incubator, the right pressures must be applied. Evolution is a problem-solving algorithm, and intelligence is a very specific and very expensive solution. For it to arise, the environment must present a unique set of challenges for which a bigger, more complex brain is the most effective answer. And the abyss presents these challenges in abundance. The first and most fundamental is the problem of perception. We have discussed how an abyssal would need to evolve an active, biological sonar to see in the dark. But let us now consider the sheer computational load of this sense. To create a high-resolution, 360-degree mental model of a complex, three-dimensional world from a constant stream of returning sound waves requires a brain of immense power and sophistication. It is a problem of physics and geometry that must be solved in every single moment of existence. This creates a relentless, direct, and powerful evolutionary pressure for increased cognitive capacity. The individual with a slightly better ability to process these signals, to build a more detailed or a faster refreshing mental map, is the individual that navigates more efficiently, finds food more easily, and avoids threats more successfully. This leads to the second pressure, the invisible arms race. In a world without sight, the ancient dance of predator and prey becomes a game of information and counter-information. It is a battle of wits, not just of speed or strength. A predator must learn to hunt by interpreting the faintest of clues to predict the movements of its prey in 3 dimensions. In response, prey must evolve ever more sophisticated methods of stealth. This might include developing skin that can absorb sonar pings, learning to move in a way that creates minimal water disturbance, or even emitting confusing jamming signals. This escalating cyclical battle of sensory acuity versus stealth is a classic driver of intelligence. It is a cognitive arms race that favors not the strongest, but the cleverest, and in this high-stakes, invisible world, cooperation becomes a game-changing survival strategy. A pack of hunters, communicating and coordinating their actions, can achieve things a lone individual never could. But to do so requires a language, a system of communication capable of conveying complex, abstract information in real time. The need to develop such a language, to plan a coordinated hunt, to convey strategy, this is a powerful catalyst for the development of abstract thought. Finally, and perhaps most importantly, there is the pressure of resource management. While the abyss is globally stable, it is locally dynamic. The hydrothermal vents, the oases that power this entire world, are not eternal. They are born, They flourish for thousands or tens of thousands of years, and then they die. For a species utterly dependent on them, the death of a vent field is an extinction-level event. This presents the ultimate evolutionary challenge, one whose solution is almost purely cognitive. The species that survives is the one that develops memory, to remember the locations of other vent fields across vast, barren plains. It is the one that develops the skill of long-range navigation, and most crucially, it is the one that develops foresight, the ability to recognize the subtle cues that a home vent is failing, and to plan and execute a great migration before starvation sets in. The ability to then pass this vital knowledge, a mental map of their world and a history of its changes, down to the next generation, is the very definition of culture. And so, we close this chapter having erected our final pillar. We have not just shown that the abyss is a possible cradle for intelligence, we have argued that it is, in some ways, a perfect one. We have a proven, non-solar engine in chemosynthesis. We have a proven, complex biosphere of extremophiles. We have a uniquely stable incubator that provides the gift of uninterrupted time. And we have a powerful set of evolutionary pressures, the problems of perception, survival, and resource management that would directly and strongly favor the evolution of a large and complex brain. The scientific case is now as complete as we can make it. The foundation is laid, and so we can now confidently leave the realm of established science and step into the world of imagination. If such a mind did arise, what would it build? What would its civilization, a world of flesh and stone, actually be like? In the preceding chapters, we have accomplished something essential. We have taken a seemingly impossible idea, that of an intelligent civilization born in the crushing darkness of the abyss, and we have built for it a firm foundation of scientific plausibility. We have demonstrated that the deep earth provides a powerful, non-solar engine in the form of chemosynthesis. We have shown that life in this realm is not only possible but complex, resilient, and masterfully adapted. And most importantly, we have argued that the unique stability and the specific environmental challenges of the abyss provide a perfect crucible for the evolution of intelligence. The stage is now set. The scientific case for plausibility is closed. Now, we can confidently leave the realm of established science and step into the world of disciplined imagination. Now, we ask the great central question of our story. If such a mind did arise, what would it create? What would a civilization born of pressure and darkness, a culture that never knew the sun, a society powered by the earth's own inner fire, actually be like? To begin this act of creation, we must start at the single most important divergence point in the history of technology, a fork in the road where their path deviated so completely from our own that it would lead to a world we would barely recognize as technological at all. We will call this the Promethean split. For our species, Homo sapiens, all of our works and wonders are children of the flame. The mastery of fire was not just one invention among many, it was the catalyst for everything that followed. It was the singular event that unlocked our potential and reshaped not just our society, but our very bodies. The cooking hypothesis, a powerful theory in modern anthropology, argues that the simple act of cooking our food was the trigger for our own cognitive explosion. Raw food is tough, difficult to digest, and often contains toxins. Cooking externalizes the digestive process. It breaks down tough cell walls and denatures proteins, making nutrients vastly more accessible. This caloric bounty allowed for a crucial evolutionary trade-off. Our digestive tracts, which are enormously energy-intensive, could shrink. The vast metabolic energy saved by this shrinkage could then be redirected to the only organ in the body that was even more power-hungry, the brain. Fire, quite literally, gave us the surplus energy we needed to grow the complex neural architecture that allows for abstract thought. The campfire became the first human institution. It was a sphere of warmth and light carved out of the primordial darkness, a shield against the predators that stalked the night. But more than that, it was a social incubator. It extended the day, giving our ancestors hours of relative safety after sunset, hours that could be filled with tool-making, social bonding, and, most importantly, storytelling. The complex, symbolic language that defines us flourished in the long, flickering hours of the fire-lit night. Fire created a space for culture to be born. From this biological and social foundation, fire became the great gateway technology, the master key that unlocked the hidden properties of the material world. Its transformative power is so fundamental that we rarely even stop to consider it. Without fire, there are no ceramics. Clay remains soft mud, and the ability to store food and water in durable, cleanable containers is impossible. Without fire, there are no fired bricks, no plaster, and no cement, the materials that allowed us to build permanent settlements and great cities. Without fire, there is no glass making, and thus no lenses for our microscopes and telescopes, the inventions that unlocked both the microscopic world and the vastness of the cosmos. And most crucially of all, without fire, there is no metallurgy. This is the absolute, non-negotiable technological barrier. The ability to take a dull, seemingly worthless rock and, by subjecting it to intense, controlled temperatures of over 1,000 degrees Celsius, to smelt it and extract from it a strong, durable, workable metal is the single most important process in our entire technological history. We name our great epochs the Bronze Age, the Iron Age, after the materials that fire gave us. Without metal, there are no durable axes to clear forests, no plows to till the soil, no swords and armor to wage organized war. There are no nails, no screws, no wires, no gears. There are no complex machines, no engines, no generators, no turbines. And of course, without the principle of combustion, there is no steam power, no internal combustion engine, no jet engine, and no rocket to carry our ambitions to the stars. Our entire global civilization, from a simple paperclip to a supercomputer, is built upon a technological tree that has the mastery of fire as its root. The abyssals would have no such root. Theirs would be a world without a spark. In their environment of cold, high-pressure water, fire is a physical and chemical impossibility. The entire concept of rapid oxidation would be a bizarre piece of abstract theory. This single, absolute constraint is the fundamental law of their civilization. It is the great divergence. And it means that every solution they devised for the universal problems of survival, construction, and energy would be, by necessity, utterly and profoundly alien to our own. So, if not fire and metal, what? If you cannot shape dead matter with high energy, you must learn to guide and shape living matter with patience and biological insight. This would be the first great pillar of their civilization, a mastery of biotechnology, so complete that the line between an organism and a tool would cease to exist. Their engineering would not be physics, it would be a form of applied genetics, advanced animal husbandry, and forced symbiosis. We will call it flesh shaping. Their workshops would not be the loud, hot, and violent environment of a forge, but the silent, glowing, and meticulously controlled environment of a nursery or an aquarium. Their tools would not be inert objects, but living, purpose-bred organisms. Consider a simple percussive tool, a hammer. An abyssal would not mine iron ore. Instead, they would cultivate a species of creature, perhaps a crustacean or a mollusk, and selectively breed it over countless generations to enhance a specific trait, a naturally hardened, calcified shell or claw, bred for density and impact resistance. Their hammers would be living things, which they would nurture and care for. A cutting tool would not be a steel blade. It would be the radula, the rasping, tongue-like organ of a giant, selectively bred gastropod. They would have learned to influence its diet and its genes to make its thousands of microscopic teeth harder, sharper, and coated in a layer of biosilica, creating a living file or saw. This paradigm of living technology would scale to incredible levels of complexity. A living drill could be a masterpiece of symbiotic engineering. A tough, muscular, and docile host creature whose mouth has been bred to house a specific colony of rock-boring, acid-secreting bacteria. The abyssal engineer would guide the host creature to a rock face, and the bacteria would go to work, their secretions dissolving the rock, while the host creature would provide the necessary pressure, rotation, and nourishment for its microbial partners. A living pump or bellows could be a massive, sessile tunicate, its powerful, muscular siphons harnessed to move vast quantities of water for civic projects. This creates a fundamentally different relationship with technology. It is not a relationship of a user to an object, but of a handler to an animal, a gardener to a plant. Their technology would be something to be fed, to be cared for, to be healed. And in their world of absolute, eternal darkness, the most precious and godlike of all technologies would be the creation of light. And so, their mastery of flesh shaping would have reached its most sublime expression in the cultivation and genetic engineering of bioluminescence. Their lighting designers would be geneticists, commanding a vast library of different species of bacteria, algae, and fungi, each one bred and modified to produce light of a specific color, intensity, and duration. Their cities would not be defined by the harsh, static glare of our electric lights, but by a silent, ever-changing, living symphony of light. Vast, slow-growing sheets of symbiotic bacteria would be cultivated on the ceilings of their great caverns, providing a soft, ambient, nebula-like glow. For more directed light, for intricate work, they might cultivate a creature with a large, lens-like organ, evolved or engineered to focus the light of its internal photophores into a tight, controllable beam. Their light would be alive. It would flicker, it would shift, it might even respond to its environment, brightening in the presence of sound or specific chemicals. Their world would be painted with a palette of soft blues, eerie greens, and ghostly whites. It would be a world of breathtaking, living beauty, an art form born entirely of manipulated life. We have now imagined a civilization whose tools, lights, and simple machines are all living, breathing organisms. This mastery of biology, this art of flesh shaping, would be a profound and powerful technological pillar, capable of solving a vast array of problems. But it alone is insufficient to build a world. A living tool can perform a task, but it needs a workshop. A bioluminescent organism can illuminate a space, but it needs a space to illuminate. For the grand, permanent structures of their civilization, their homes, their cities, their highways, the abyssals, would have turned to the other great active power in their world, the raw, untamed, geological energy of the planet itself. If their first pillar was the manipulation of life, their second would be the manipulation of the non-living world through an intimate and sophisticated understanding of temperature, pressure, and chemistry. This is the mastery of geology, the art of stone shaping. Their relationship with their planet's geology would be fundamentally different from our own. We view the Earth as a mostly inert resource, a dead quarry from which we extract materials. We see geological forces like volcanism and tectonics as unpredictable and destructive threats to be avoided. For the abyssals, these forces would be the very heart of their world, a constant, dynamic process to be understood, harnessed, and guided. Their engineering would not be about imposing a rigid, human order onto a passive landscape, but about a subtle, patient partnership with the planet's own creative energies. They would be geological shepherds. The foundation of their stone-shaping technology would be the ability to control and direct the flow of the superheated, mineral-rich water from the hydrothermal vents. We see these vents as chaotic natural wonders. They would see them as raw, untamed power tools. Having mastered biotechnology, they could grow tough, heat-resistant, coral-like organisms to create conduits, dams, and nozzles, allowing them to tap and redirect these geothermal flows. A focused, needle-thin jet of 400-degree supercritical water is a thermal lance of almost unimaginable power. Over time, it can carve through solid basaltic rock with a precision and grace that no mechanical drill could ever hope to match. Their great construction projects would be undertakings of immense patience and foresight. An abyssal city would not be built in a single generation. Its primary caverns and halls would be carved over millennia by a handful of geological engineers who would expertly guide these thermal flows, creating vast, vaulted, impossibly smooth-walled chambers deep within the oceanic crust. Their architecture would be one of elegant subtraction. They would not build highways by laying asphalt. They would carve them, creating a vast, subterranean network of protected, interconnected tunnels, a planetary subway system linking the great vent fields of a tectonic plate. At a more advanced stage, their understanding of geology would become predictive and even proactive. As the ultimate seismologists, they could learn to read the faint, telltale tremors and chemical signals in the crust that foretold the birth of a new vent field or the slow, inevitable death of an old one. This would allow them to manage the life cycle of their civilization over geological timescales. At the very apex of their power, they might learn not just to predict, but to influence. By using their biodrills to create networks of relief tunnels, they could alter the pressure gradients deep within the crust, subtly encouraging the formation of a new, life-giving hydrothermal vent in a location of their choosing. This would be their equivalent of building a new power station or founding a new city. It would be an act of profound, planetary-scale engineering. But carving tunnels and guiding vents is only half the story. The true artistry of their stone shaping, the technology that would provide their most advanced materials, would lie in their mastery of mineral precipitation. The vent fluid is a supersaturated chemical soup. When this 400-degree fluid erupts into the near-freezing ocean, its massive payload of dissolved minerals crashes out of solution almost instantly, precipitating in a chaotic, disorganized manner to form the brittle, porous structures of the black smoker chimneys. The abyssals would look at this process and see not chaos, but boundless potential for creation. They would learn to control it, to tame this wild chemistry, and become masters of controlled, large-scale crystallography. Their methods for achieving this control would be a beautiful synthesis of their geological understanding and their biological technology. By building sophisticated dams and mixing chambers, they could precisely manage the thermal gradients where the hot and cold water met, slowing down the rate of precipitation from seconds to days or even years. This slow, controlled process would allow for the growth of massive, perfectly ordered, and incredibly strong crystals instead of the weak, chaotic conglomerates of a natural chimney. Their most powerful technique, however, would be the use of chemical seeding, and it is here that their two great technological pillars would intersect. They would use their mastery of biotechnology to design and produce complex organic molecules, or even entire, living bacterial colonies that would act as perfect templates for mineralization. An abyssal architect, wishing to create a great translucent wall, would begin not with stone, but with life. They would spend years, or even decades, cultivating a vast, sheet-like bacterial mat, growing it into the precise, desired three-dimensional shape of the final wall. The cell walls of these bacteria would be genetically engineered to be perfect nucleation sites, molecular magnets for specific minerals like silica. Once this living, bacterial blueprint was complete, they would carefully introduce the superheated, mineral-rich vent fluid. As the fluid flowed over the scaffold, the targeted mineral, in this case, silica, would precipitate out of solution and bind to the bacterial cell walls. Molecule by molecule, layer by layer, the living blueprint would be entombed, fossilized, into a solid, monolithic structure of impossibly pure, perfectly ordered, transparent quartz. They would not build a wall. They would grow one, first in flesh and then in stone. This technology of controlled crystallization would be their equivalent of steel, concrete, and glass, and in many ways it would be far superior. They could create a vast palette of materials with specifically engineered properties. They could grow opaque, interlocking metallic sulfide crystals for immense structural strength. They could grow vast, flawless, translucent sheets of silica for their dwellings. They could grow crystals with specific resonant frequencies to be used in their acoustic arts and technologies. They could even, perhaps, learn to grow piezoelectric crystals capable of generating an electrical charge when subjected to pressure, providing a secondary, decentralized source of power throughout their cities. With these two pillars in place, the shaping of flesh and the shaping of stone, we can finally begin to visualize the abyssal city. It would be a place of breathtaking, alien grandeur, a perfect fusion of the biological and the geological. The city's macrostructure, its great bones, would be the vast, echoing caverns carved from the native basalt by patient thermal lances. Within these protective primary halls, the city's internal structures, the dwellings, the nurseries, the great halls of sound, would be the grown crystalline forms, their organic, flowing shapes fused seamlessly to the living rock, not as separate buildings, but as integrated organs of a greater whole. This city would have a metabolism. It would be powered by a complex circulatory system of carved channels, great arteries transporting the primary geothermal fluid for heat and manufacturing, and smaller veins delivering specific chemical mixtures for construction and for feeding the city's vast, integrated biological systems. The city would breathe, its atmosphere, the water within it, managed and purified by immense, living, filter-feeding organisms built directly into the architecture. It would be a city that could heal itself, a city that could grow. It would be a single, vast, engineered superorganism. We have now, in our minds, built the physical world of the abyssals. We have conceived of their living tools, their grown technologies, and their great cities carved from the bones of the planet and illuminated by a living light. We have constructed their alien workshop, but a workshop, however wondrous, is nothing without a craftsman. To truly understand the soul of this hypothetical civilization, we must now undertake the most difficult and most speculative leap of all. We must attempt to imagine the mind that would inhabit such a world. A civilization's technology is a reflection of its needs, but its culture, its philosophy, and its very consciousness are a reflection of its senses. To understand how the abyssals would think, we must first understand how they would perceive reality, and to do that, we must abandon our most cherished and most tyrannical sense, our sight. Our consciousness is, in almost every way, a visual consciousness. A third of our brain's immense processing power is dedicated to interpreting the photons that strike our retinas. We think in images, we dream in images. Our languages are saturated with visual metaphors. We see a point, we have bright ideas, we look for clarity. The abyssals would have none of this. Their consciousness would be forged in a different sensory fire altogether, a reality woven not from light and shadow, but from a constant flowing symphony of sound, pressure, chemistry, and electricity. Their primary, world-building sense would be their active biological sonar. But to call this echolocation is a profound understatement. We must not think of it as a simple tool for avoiding obstacles, but as a true form of vision, as rich and detailed as our own, but with a set of properties that are completely alien to us. An abyssal would perceive their world as a landscape of acoustic textures. A soft, muddy seafloor would look dark and absorbent to them, a place where sound goes to die. A hard crystalline wall would be brilliantly reflective, a mirror of sound. The soft flesh of a living creature would have a completely different acoustic sheen than the porous surface of a volcanic rock. They would navigate a world they could feel, in detail, with sound. But this sense could be far more powerful still. With a wide enough range of frequencies and enough processing power in their brains, their sonar could function as a form of natural, real-time ultrasound or magnetic resonance imaging. They would not just perceive the surface of an object, they would be able to see inside it. They could perceive the internal crystalline structure of a rock, searching for flaws or valuable inclusions. They could see the internal organs of another creature, its bones, its muscles, its digestive tract. This would make their world profoundly and uncomfortably transparent, and it would have a staggering impact on their social interactions. Imagine being able to perceive the involuntary physiological state of another being as clearly as you perceive their physical form. You would not have to guess if they were afraid or aggressive. You could directly perceive the frantic, panicked beating of their heart, the tightening of their muscles, the rush of fluid through their circulatory system. In a world of acoustic transparency, deception as we know it might be a psychological and social impossibility. Their society would have to be built upon a foundation of almost total, biologically enforced empathy and honesty. This acoustic vision would be just one layer in a multi-sensory torrent of data. Their entire bodies would be sensory organs. Their skin, a vast network of receptors would allow them to read the language of the water itself. They would feel the subtle, sighing pressure wave of a distant geological event, reading the very pulse of their planet. They would feel the lingering, turbulent ghost of a creature that had passed by moments before, its signature still hanging in the water. And in this liquid world, their chemical senses would be astonishingly potent. Taste and smell would merge into a single, powerful sense, allowing them to read the history and the present state of their environment. They could taste the faint, decaying trail of a potential meal from miles away, or the unique mineral signature of a specific hydrothermal vent. This chemical sense would almost certainly have become a vital component of their language. Their communication would be a multi-layered, multi-sensory experience, a total language. A vocalized statement, rich with the clicks, chirps, and resonant frequencies of their acoustic vocabulary, could be accompanied by the simultaneous release of a complex, engineered pheromone. This chemical signal could carry the emotional context of the statement, irony, sadness, reverence, urgency, a layer of meaning that would be completely imperceptible to us. It would be a language that is both heard and tasted, a form of communication so dense with data that our own spoken words would seem like a crude and primitive tool in comparison. And woven through all of this would be their life sense, their electroreception. By sensing the faint bioelectric fields generated by the nervous systems of all living things, their world would be populated by ghostly, glowing auras. A creature hiding in a crevice, perfectly silent and still, could not hide the vital spark of its own mind. Hiding, in any conventional sense, would be nearly impossible. This would create a world of very few secrets. What kind of social structure, what kind of soul would arise from such a sensory environment? In a world of acoustic transparency, chemical honesty, and constant ambient awareness of others, it is highly likely that the very concept of the individual as we understand it, a discrete, private, isolated consciousness, might never fully develop. Their natural state would be one of connection, of enmeshment. They would exist in a state of ambient intimacy, always passively aware of the presence, location, and emotional and physical state of their kin. This would almost certainly lead to a profoundly communal or collective society. They might be less like a collection of individuals and more like a superorganism, a great hive mind bound together not by some mystical telepathy, but by a constant, overwhelming, and shared flood of real, physical sensory data. Their sense of self might be a we before it is an I. From this collective soul, their culture and art would blossom. But what is beauty without light? What is art without an image? Their highest art form would be the art of sound and space. A great abyssal artist would not be a sculptor who carves a statue to be looked at. They would be an acoustic architect, a composer who designs a vast cavern, or a crystalline chamber with precise, calculated resonant properties. The art would not be the chamber itself, but the experience of being within it. The civilization would gather in these great cathedrals of sound, and by producing choral, resonant vocalizations, they would play the architecture. The resulting patterns of overlapping echoes, constructive and destructive interference, and standing waves would create complex, moving, three-dimensional acoustic images and profound physical sensations in the minds and bodies of the participants. Their music and their architecture would be one and the same. Their other great art form would be the slow, hypnotic ballet of their cultivated bioluminescence. Their paintings would be the living walls of their cities, vast canvases of bacteria engineered to shift through complex, pre-programmed patterns of color and light over vast periods of time. An abyssal epic poem might not be written in a book, but encoded into a living wall, a story that would take 1,000 years to unfold in its silent, flowing, luminous calligraphy. And with their hyper-developed chemical senses, their culinary arts would be a high form of expression. An abyssal chef could create a complex symphony of flavors and scents, released into a specific chamber, designed to evoke a precise set of memories and emotions, an art form as sophisticated and moving as any of our great musical compositions. And what of their philosophy? A civilization with no knowledge of a sun, a moon, or a star would have a profoundly different cosmology. Their universe would be the planet itself. Their search for meaning would be an inward-looking journey, not an outward-looking one. Their gods would not be sky beings, but the great, tangible, and active forces of their world, the core, whose unimaginable heat was the source of all energy and life, the mantle, whose slow, grinding dance shaped their reality and measured out the ages, and the ocean, the great, conscious medium that connected all things. Their concept of time itself would be geological, measured in the long, slow life cycle of a vent field or the ponderous drift of a tectonic plate. They might not see a distinction between life and non-life, viewing the entire planet as a single, great, living organism, and all creatures, themselves included, as temporary, mobile expressions of the planet's inner fire. Their philosophy would be one of deep and total connection, of an ecological integration so complete that they would see their cities not as an imposition on the world, but as a new and beautiful organ of the living planet itself. We have now completed our portrait. We have imagined a civilization of profound and beautiful alienness, a collective society of beings living in cities that are both alive and stone, perceiving their reality through a symphony of senses we can barely comprehend, and whose entire culture is a deep and intricate reflection of the geological forces that gave them birth. We have built their world in our minds, but our journey cannot end in this realm of pure imagination. We must now return to our own world, to our own science, and ask the final, most difficult, and most important question. If this civilization, or anything like it, ever existed, where are they now? In the preceding chapters of our journey, we have done something audacious. We have taken a sliver of scientific possibility, the existence of chemosynthetic life, and from it, we have spun a rich and detailed vision of a world. We have built a hypothetical civilization from the ground up, imagining their living technologies, their geologically grown cities, and the strange, multi-sensory consciousness that would animate them. It is a compelling, internally consistent, and wondrous picture. But it is, for now, just a story. Our journey cannot end in the realm of imagination. We must now turn back to our own world, to our own science, and confront the hardest, coldest, and most important question of all. Is there any proof? If this civilization, or anything remotely like it, ever existed, what traces would they have left behind? Here, our role shifts. We are no longer scientists building a hypothesis or philosophers speculating on its nature. We are now detectives, arriving at a crime scene of unimaginable scale and antiquity. The potential victim is an entire civilization. The time of death was millions of years ago, and the evidence has been subjected to the most relentless and efficient cleanup operation in the universe, a process of erasure, conducted by the planet itself. The abyss keeps its secrets well, not through malice, but through the relentless, indifferent churn of biological and geological time. If the abyssal civilization was a grand symphony of life, then all that is left for us to find is the silence that follows. To begin our search, we must first understand the monumental challenge we face. Human archaeology is a science of survivors. We find things that last. A shard of pottery, fired in a kiln, is a piece of man-made rock that can endure for millennia. A flint arrowhead is a tool that is almost as durable as the planet itself. A gold coin is made of a metal that does not corrode. The foundations of a stone building resist the ages. Human history is legible to us because our ancestors made their world out of durable, inorganic materials that could defy decay. The abyssal civilization, as we have imagined them, built their world from the most ephemeral material of all, life. Their technology was overwhelmingly organic. What happens to a living tool when it is discarded? It dies. Within hours, its surface would be colonized by a film of bacteria, the primary decomposers. Within days, the scavengers, crabs, fish, worms would begin to tear it apart. Within years, its complex organic molecules would be completely broken down and reabsorbed into the ecosystem. The same fate would befall their architecture. A grown wall is still flesh. Without the civilization to maintain it, it would be consumed. Their living cities would not fall into ruin. They would be eaten. Even this assumes we could find the site. The second great force of erasure is geology itself. The floor of the deep ocean is not a static museum. It is a dynamic, constantly recycling surface. The first process is sedimentation. For millions of years, a constant, gentle, and inescapable rain of marine snow, the dust of dead plankton, fish scales, and continental dirt has been falling upon the seafloor. This process is slow but relentless. Over 1 million years, a layer of muck and ooze hundreds of feet thick can accumulate, burying everything beneath it in a dense, suffocating blanket. A structure the size of a city, left untouched for 10 million years, could find itself buried beneath a sediment layer so thick our modern instruments could barely penetrate it. And if burial isn't enough, there is the final, ultimate destroyer: subduction. The ocean floor is a giant conveyor belt. At the mid-ocean ridges, new crust is formed. From there, it slowly spreads outwards, carrying everything on it. At the other end of its journey, it meets a continent and plunges back down into the Earth's mantle, where it is melted back into magma. This process destroys the ocean floor and everything on it. The entire Pacific Ocean floor, for example, is recycled on a timescale of about 150 to 200 million years. This means that if our abyssal civilization existed, say, 300 million years ago, the very ground they lived on may no longer physically exist. It has been consumed by the planet. Faced with these two immense forces, total biological decay and active geological destruction, the search for evidence seems utterly hopeless. But there is a final, more subtle challenge: our own profound biases. We are the children of lines and squares. Our civilization is built upon Euclidean geometry. We look for right angles, straight roads, the foundations of square buildings. Our archaeological search patterns are designed to find the familiar. We are utterly unprepared to search for the ruins of a civilization that built with flowing curves, that carved tunnels with heat, and whose grandest structures were living, crystalline reefs. We are looking for needles in a haystack, without even knowing what their needles would look like. So, where do we begin? We must look not for artifacts, but for anomalies. We must look for things that, while seemingly natural, are profoundly improbable. Our first category of evidence is not archaeology, but geology. We must search for the unnatural natural features that, while made of rock and explainable by natural laws, are so geometrically or chemically improbable that they demand a better explanation. Our first and most promising category of evidence would be the discovery of impossible geometries. Nature, for all its complexity, is governed by the predictable laws of physics and chemistry. These laws produce characteristic patterns, the fractal branching of a river delta, the hexagonal columns of cooling basalt, the jagged, chaotic lines of a fault zone. Nature is an artist of fractals and chaos. It is rarely, on a macro scale, an artist of pure, abstract mathematics. Intelligence, on the other hand, is capable of imposing such forms onto the world. A perfect sphere, a perfectly circular tunnel, a perfectly flat plane extending for miles, these are the hallmarks of design, not of chance. Imagine a scientific drilling vessel, like the Joids Resolution, taking core samples from the deep Pacific. For weeks, their drill chews through thousands of feet of sediment and then into the hard, solid basalt of the ancient oceanic crust, exactly as predicted. But then, suddenly, the drill bit punches through into a void. The instruments register a massive, open space where there should be millions of tons of solid rock. They retract the drill and lower a camera. On the screen in the control room, they see not the jagged, irregular walls of a natural lava tube, but the wall of a tunnel so vast and so perfectly circular, it looks like it was made by a colossal boring machine. This is the kind of evidence we are looking for, a profound, geometric anomaly that defies its geological context. To understand the maddening ambiguity of such a discovery, we need only look to the real-world mystery of the Yonaguni Monument, submerged off the coast of Japan. This colossal stone structure, the size of a pyramid, has features that seem stubbornly artificial. Vast, flat terraces, towering vertical walls that look like they were cut, and a section that is uncannily like a giant staircase with sharp, right-angled steps. Geologists, for the most part, insist it is a natural formation. The rock is sandstone, which tends to fracture along straight plains, and they argue that millennia of strong currents and natural erosion created the spectacle we see today. But many others are not so sure. The monument has features that seem stubbornly artificial. It has vast, flat terraces, towering vertical walls that look like they were cut, and a section that is uncannily like a giant staircase with sharp, right-angled steps. It straddles a terrifying line. It is just natural enough to be plausible, and just artificial enough to be incredible. There is no writing, there are no discarded tools, there is only the shape of the thing itself. The Yonaguni Monument is the perfect template for the kind of evidence we might find of an abyssal civilization. It would be a feature of the landscape. It would be something we could explain away with a convoluted but possible geological theory. It would whisper, never shout. The ruins of their geologically engineered cities would, after millions of years of erosion and mineral accretion, look like strange but natural rock formations. The evidence would always provide us with just enough plausibility to dismiss it as a trick of geology, a curiosity. To find the truth, we would have to learn to recognize the signature of intelligence, not in a discarded artifact, but in a profound and lingering improbability in the stone itself. Discovering an impossible geometric structure deep within the Earth's crust would be a paradigm-shattering moment. Yet, it would also be a singular, tantalizing clue, a geological Rorschach test onto which we could project our own hopes and biases. To build a truly compelling case for a lost abyssal civilization, we would need to move beyond the search for grand, physical structures. We would need to zoom in, to shift our perspective from that of an architect to that of a forensic chemist. We must search for the evidence not in the shape of the rock, but in the very molecules of the ancient mud that covers it. We must search for their chemical ghosts. This is the field of geochemistry, and it is here that the most subtle, but perhaps most convincing evidence may lie. While the organic bodies of the abyssals and their living tools would have been recycled, the combined biochemical processes of billions of organisms living for millions of years would have inevitably altered the chemistry of their environment. They would have left a fingerprint. One of the most powerful forensic tools at our disposal is the analysis of isotopic ratios. Most elements on Earth exist in several stable forms, or isotopes, which have slightly different masses due to a different number of neutrons. For example, the vast majority of carbon is carbon-12, while a tiny fraction is the slightly heavier carbon-13. Crucially, life is lazy. Biological processes, from bacterial metabolism to photosynthesis, find it easier and more energy efficient to work with the lighter isotopes. Imagine a buffet with heavy and light food items. Life preferentially grabs the lighter, easier to process items. Over time, the accumulated waste, organic matter, will be enriched in the light items, and the leftover buffet, the atmosphere, ocean, will be slightly enriched in the heavy items. This is not just a theoretical curiosity. We can see this process happening in real time, caused by our own industrial civilization. As we burn colossal amounts of fossil fuels, which are ancient, C12-rich organic matter, we are releasing this light carbon back into the atmosphere, measurably lowering the global ratio of C13 to C12. This phenomenon, known as the Suez effect, is a permanent, global, geochemical signature of our industrial activity. A future geologist, millions of years from now, could analyze the isotopes in a layer of rock from our time and see a sharp, dramatic spike that screams a global event involving the massive processing of organic carbon was happening here. An abyssal civilization, with a biosphere potentially numbering in the quadrillions, all processing geothermally sourced carbon, would have left an analogous and equally dramatic signature. Their biochemistry would have had its own unique isotopic preferences for carbon, and especially for sulfur, given its central role in their energy production. In a deep-sea sediment core, drilled from the ocean floor and dating back to their era, we might find a sharp, inexplicable shift in the ratio of sulfur-32 to sulfur-34, or a carbon spike that has no corresponding surface event. It would be a chemical fingerprint of a lost, global metabolism. It would be the silent, chemical scream of their biosphere. Beyond the broad signature of isotopes, we could hunt for more specific clues, biomarker molecules. Think of these as molecular fossils. When an organism dies, most of its complex molecules, like proteins and DNA, break down quickly. But some molecules, particularly the lipids and sterols that make up cell membranes, are incredibly tough and resistant to decay. These molecular fossils can be preserved in sediment for hundreds of millions of years, acting as a chemical fingerprint of the type of life that existed at the time. We use them today to understand ancient ecosystems, For example, finding a specific type of sterol called dinosterane in a rock layer is a definitive sign that dinoflagellates were present. Now, imagine our scientists are analyzing a deep-sea core sample from a layer of rock dated to 200 million years ago. Inside it, they find a whole suite of incredibly complex, unknown lipid molecules. These molecules are clearly biological in origin, but they do not match the molecular signature of any known domain of life on Earth. They are not bacterial, not archaeal, and not eukaryotic. They are something other. It would be the chemical equivalent of finding a stainless steel bolt in a sealed dinosaur fossil. It would be a tangible, molecular remnant of a lost branch of life, a domain X, whose existence could only be explained by a completely separate genesis or by an act of deliberate, intelligent design from a civilization that had mastered biotechnology. This chemical forensics could also extend to anomalous elemental concentrations. The civilization we have imagined was not just biological, it was geological. It actively manipulated mineral-rich fluids and precipitated vast crystalline structures. This industrial-scale geochemistry would have inevitably produced waste. Their process of purifying certain minerals for their constructions would have created large amounts of tailings, enriched in other, unwanted elements. This waste would have been released into the environment. In the sedimentary record, this could manifest as a thin, bizarre layer of rock with an impossible combination of elements. Perhaps a layer with a startlingly high concentration of rare earth elements like neodymium and yttrium, alongside biologically important metals like cobalt and manganese. A geologist would be at a complete loss to explain a natural process that could selectively concentrate this specific, motley collection of elements in one place. It would defy all known models of volcanism and sedimentation, but it could be perfectly and simply explained as the chemical dump site of an ancient, advanced civilization. Finally, we must allow ourselves one last, speculative leap into the deepest realms of this search. We must consider the most poetic and most improbable form of evidence they might have left behind. Let us return to the nature of their perception. We imagined a civilization whose primary sense was sound, whose art and architecture were acoustic. Sound is not an abstract concept, it is a physical wave of pressure, a vibration that carries energy through a medium. We know that a singer, hitting a precise frequency with enough power, can cause a crystal glass to vibrate so violently that it shatters. This is resonance, a physical and destructive interaction between sound and matter. Now, imagine not a single note, but millions of years of complex, powerful, resonant frequencies being generated within and around vast, crystalline structures. This is the sound of their language, their technology, their art, their very existence. Could these paleoacoustic vibrations have left a permanent, physical mark? It is a fascinating, if highly speculative, thought experiment. The constant, specific frequencies would not have been strong enough to shatter the great crystalline walls of their cities, but over geological time, they could have left a more subtle trace. They could have influenced the very alignment of the crystals as they grew, locking a preferred vibrational pattern into the stone's fundamental structure. It is possible that the most complete record of their civilization, their language, their history, their songs is not written in a book, but is encoded as a series of microscopic imperfections in a seemingly dead piece of rock. We currently have no technology to even begin to search for such a clue, let alone to decipher it. But it is a profound thought that the ruin of their greatest cathedral might not just be a silent cave, but a frozen symphony. And so, we have laid out the daunting task of the abyssal archaeologist. The search would be a multifaceted investigation for a pattern of anomalies. There would be no single smoking gun. The proof of their existence would be in the convergence of the evidence. Imagine a single deep-sea survey that discovers a region of the seafloor containing a network of impossibly smooth tunnels. A core sample from that region reveals a sedimentary layer dated to the same period, with a wild isotopic anomaly and a suite of biomarker molecules from an unknown domain of life. When analyzed, the crystalline rock of the tunnels is found to have microscopic structural patterns that defy natural explanation. Individually, each of these findings is a mystery. Together, they are a manifesto. This investigation, however, is predicated entirely on the fact that we are searching for a civilization that is gone. We are sifting through the ashes. It leads us, inexorably, to the final, most chilling question of our entire journey. If they were here, if they built a world that lasted for eons, what happened to them? Why is the abyss now silent? The answer to that question may hold the most important lesson of all. Our long journey is at last coming to an end. We have plunged from the familiar sunlit surface into an alien world within our own. We began with a simple, unsettling question. What if we are not the first? From that question, we built a scientific case for the plausibility of an intelligence born in the abyss. We then gave that intelligence a form, imagining its living technologies and its cities of stone and flesh. Finally, as detectives, we have sifted through the geological ages for the faint, ghostly traces it might have left behind. This entire, sprawling thought experiment has led us to this final moment, to this final, silent, and empty stage. And so we must ask the ultimate question: if the abyssals were ever here, what great tragedy or what great transformation led to their disappearance? The answer, of course, is lost to time. But in the possible solutions to this final mystery, we may find the most important lessons of all. Each hypothesis for their extinction is a dark mirror reflecting a potential fate for our own civilization. Perhaps their end came from within, a cautionary tale of intelligence turning upon itself. Their mastery of biotechnology, their ability to shape and create new forms of life, could have been their undoing. Imagine a genetically engineered organism created as a tool or a food source that mutated beyond their control. A biological plague perfectly adapted to their unique physiology, spreading through their interconnected cities with unstoppable speed. Or perhaps a form of gray goo, but biological, a synthetic microbe designed to consume waste that evolved to consume everything, turning their entire living world into a soupy, undifferentiated biomass. In our own age of CRISPR and synthetic biology, this possibility feels uncomfortably close to home. Alternatively, their mastery of geology could have been their downfall. In their ambition to create new homes or harness more energy, they might have tampered with forces they did not fully understand. An attempt to carve a new transcontinental tunnel could have destabilized a tectonic plate. An effort to create a new hydrothermal vent could have backfired catastrophically, triggering a massive tectonic event, a chain reaction of eruptions that sterilized their entire section of the planet's crust. It is the ultimate parable of hubris, a warning that tampering with the fundamental operating system of a planet can have consequences that are both unforeseen and absolute. Or perhaps their end was not so dramatic. Perhaps it was a slow, quiet, and inevitable decline. They were safe from the chaos of the surface, but they were not safe from the long, slow life cycle of the planet itself. The Earth's core, their distant, fiery sun, is not eternal. Over hundreds of millions of years, the geothermal output of the planet wanes. The great engine of plate tectonics slows. The hydrothermal vents, which were the very foundation of their existence, would have become less frequent, less powerful, and would have eventually, one by one, gone cold. Theirs would have been a slow, tragic extinction, a civilization clinging to the last embers of a dying planetary fire, a story not of a sudden cataclysm, but of a long, final winter. It is a profound reminder that no civilization can outlast the life of its star, whether that star is in the sky or at the center of the world. And then there are the stranger, more hopeful, and far more unsettling possibilities. What if they did not die at all? What if, faced with the slow decline of their world, they used their immense knowledge to transcend it? Perhaps they evolved beyond the physical form we have imagined, uploading their collective consciousness into the vast, crystalline structures of their cities, becoming a thinking planet, a geological mind. Or perhaps they simply moved on. Their technology of flesh and geology could have allowed them to venture even deeper, to escape the ocean floor and migrate into the theoretical, subterranean oceans of liquid water that may exist deep within the Earth's crust, becoming a truly hidden world. And of course, there is the most unnerving thought of all, that they are still here, silent, aware of the frantic, noisy, short-lived civilization of fire and metal that has infested the thin, dry shell of their world. And they are watching, listening, and, for reasons of their own, choosing not to be found. In the end, we have no evidence, and we may never have an answer. But the purpose of this thought experiment, the journey to the abyss, was never truly about finding a lost civilization. It was about holding up a mirror to our own. This is the purpose of the PsyBox, to open a container of ideas that forces us to look at ourselves in a new light. The story of the Abyssals is one such mirror, and in its dark, silent surface, it shows us ourselves in three unsettling reflections. First, it reflects our profound biases. The entire thought experiment forces us to confront the fact that our way of being, our reliance on sight, our mastery of fire, our technologies of metal and combustion is not a universal template for intelligence. It is a local, contingent path, the result of the specific environment in which we evolved. The Abyssals show us that another path was possible, and that our assumptions about what to look for in the universe may be profoundly, cripplingly wrong. Second, their hypothetical story reflects our own breathtaking fragility. We, humanity, have had a civilization capable of recording its own history for perhaps 6,000 years. We have had industrial technology for less than 300. We act as if we are the permanent masters of this planet. The Abyssals, who may have flourished for 100 million years before vanishing into geological time, provide a dose of profound, cosmic humility. Their utter disappearance is a mirror for our own legacy. It forces us to ask, in 100 million years, what will be left of our great cities, our art, our science? Will there be even a single, anomalous molecule to prove that we were ever here? And finally, and most importantly, the abyss itself is a mirror reflecting our own ignorance. We stand on the shores of a vast, cosmic ocean and cast our nets for signs of life on worlds light years away. It is a noble and worthy quest, but we do so while standing on the lid of another ocean, an inner world that is vaster, more mysterious, and more unexplored than the surface of Mars. We are a civilization that dreams of aliens while living on a planet that is still, for the most part, alien to us. The great lesson of the abyssals is not that we should stop looking up at the stars. It is that we must also, with the same passion, the same resources, and the same sense of awe, start looking down. The answers to our deepest questions about the origin of life, the nature of intelligence, and our own place in the universe may not be found in the faint signals from a distant sun. They may be locked in the ancient mud of our own seafloor. They may be waiting for us in the crushing, silent, and beautiful darkness that has been here all along, right beneath our feet.